Okay, so here's a quick one. Someone was asking about bounds and what that is. Bobcat's entity summary could have more options to deal with it, but it's just limited. So here's my best stab at explaining it, not being a geometry expert who might explain it a little differently. So here's a curve in Bobcat, right? Looks like it's well below Z, huh? And so where we're experiencing this is in imported products using like an IGES format or something. It's how this data right here is stored in that file, and it has to be able to store the curve and its creation process and everything. So, like if we entity summary this curve right here that's well below Z, um, why is it giving us a Z plus value of 4.0734? What could that, it's obviously well below Z. But now we're going to look at the same curve in another program, uh, one of my favorites, by the way, that that shows this curve and its creation. So I can turn on these control points, and this NURBS B spline um, actually has points that are, this line right here is the Z. So I'll show you this line right here goes across is Z0. So I can actually measure if I snap onto that point and just go down to Z0, right? Look, the length of this line is 4.073. So that point right there, which is what's defining that spline, is at that Z value that you're looking at. Same thing with the bottom Z value. This one right here would be included in that summary. Now, so we can go back into Bobcat, and if you run some kind of transform on this curve, like say for instance, let's just run arc fit on it, just a default value. It's been transformed, which means those points no longer exist. Bobcat doesn't work in that manner. So now if you do an entity summary, you'll see it's minus 1.0446. So now that's exactly where that is. And the same thing kind of goes for the solids too, which would be, let's bring up a solid real quick. Um, Even though your solid appears to be at zero, you NURBS surfaces are made of what's called trim curves and stuff. So there's an underlying surface that still exists, and that data has to transfer around between the programs. So if we turn on the points for this, looking straight in on it, look at those points that are well above the surface there. Same thing, especially for fillets and stuff too. Like this bounding cage goes way out here, which defines that surface. And even for that fillet, see these points that that have to define that curved surface there, right? And and so then that's why when you when you extract the edges, then it's actually transforming. You Bobcat brings that edge out, and then it just becomes an entity right where it's supposed to be. So uh, just like with transforming curves, if you just make a plain old box in some other program at Z0 going down, and then you go and you export it in a format like IGES, then when you import it into Bobcat, it's got to keep all the bounds data and the stuff that all that data that's the creation of that. And so if you just make a plain box, you say, well, what's higher than that surface? Well, it's just the data that's defining the surface. And you could tell that by make a box in one of your other favorite programs and bring it into Bobcat. It's supposed to be at Z0, but it entities at 0.002, for instance. And then what you can do is if you take that top surface uh, and untrim it, use Bobcat's untrim tool, then you will see that that basically transformed that box again, and now it entity summaries at zero because it's a new definition within the window. Uh, I think R. Miller asked, how come other programs can handle it different? Well, more time and energy and money put into those mechanisms. Bobcat's entity summary is just doing it that way. I was asking them about this a few years back, and basically it's just that's what we got so far. I don't know that they need something else to change it. They'd have to put a lot of time into the entity summary to be able to do that. So anyway, blah blah blah. That's kind of a visual on what bounds data is. Hope that helps. Bye.